The following equations represent reactions in galvanic cells. The proper species are present, but the equations are not balanced. Add coefficients where necessary to balance the equations. Note at the bottom here, each of these reactions is occurring in an acidic medium, hence the H+ is present on the reactant side. The College Board will typically ask a question like this, where you just add the coefficients to balance. So let's take our first equation here. And the first thing you do, make a little table and count the species on both sides, and then add coefficients so that the number of each species is equal on both sides. So I'm not going to go through that. We've done that a lot in the past. So you each have your own methods for doing it, and hopefully you can get to this answer right here. And that shows that the species are balanced. Now let's see if the charges are balanced. So we're going to look at the left side, and we have plus 16 here for the hydrogen, 2 times minus 2, and then 0, and we get 12, so that's good. And look at the right side, 4 times 3 is 12. What do we have over here? That's 0. This is also 0, so 12 equals 12. And then you can count each element's charge and see if they balance, which they do. Another equation, and again, just first write what we're given in the unbalanced equation, and then play around with that until you can get the balanced equation here, where you have the same number of each atom on each side. Now let's check to see if the charge is balanced. Well, let's see. On the left side, we have 8 times negative 1, plus 0, plus 0, plus 0. On the other side, 4 times negative 1, plus 4 times negative 1 is minus 8. And also, that will work out for the elements. And the last problem, same thing. We list what we start with here in a little table. Then we work with the equation until we can get the elements to balance. So that's all good. Now check that the charges are balanced. Let's see, 2 times negative 1, 6 times plus 1, 5 times negative 1, and that gives us a negative 1. That's good. The other side, plus 4, 0, minus 5, minus 1. It works. We're good.